If you think URL shortener is just about taking a long URL, generating a shorter one and redirecting users back to the original one, then you have just seen the tip of the iceberg. I just spent last week developing a production grade URL shortener, and this thing is an absolute monster. We're talking about clean architecture, security layers, background worker, Prometheus metrics, and Grafana dashboards that is used to collect logs and visualize them for your application. This isn't just a CRUD app, it's a distributed system in a single repo. Now I'm gonna show you how it works. Let's go. Let's log in. Click new short URL here. Paste your longer URL. If you want, try a custom alias. Let's say resume. Let's set TTL to 2 days, shorten URL. And that would give you a short URL with your custom alias. And if I go to this URL, you get redirected to the original one. Simple, right? Except this thing has user authentication, click analytics, abuse reporting, admin moderation, custom aliases, link expiry, CSV export, and 6-tier rate limiting. That's a lot. And if you are admin, you can watch everything by going into admin section. You can manage all the users. Currently, I'm the only one. You can toggle their role to promote them to admin. You can deactivate or delete a user. So if I create a URL with that domain, you can see it currently works. But as soon as I add google.com in block list, it no longer works. Users can place abuse reports, which you can view from here, and you can mark them as reviewed. After reviewing them, you can dismiss them if you think this is a false positive, or you can take an action on them. Users can create reports just by going over report here. You can override the default rate limiting for a user or an IP address. You can view the system health to see all of the components of your application are in working condition. And you can view all the usage analytics of your URL just by clicking the analytics button here. And it will show you total clicks, unique referrals, devices. It will show you clicks over time. It will show you from which URL your URL was referred. And it will also show you device breakdown. So this thing gets 3 tiers of rate limiting. If you are a guest, you get to shorten links but at 5 requests per minute. If you are authenticated, you get boosted to 100 requests per minute. And if you are admin, you get the keys to the kingdom. So let's see how this thing is structured. This is a clean architecture with 3 layers. And if you're thinking, clean architecture for a URL shortener, isn't that an overkill? Then you need to hear me out. The inner layer or domain has 0 framework imports. No fast API, no database, nothing. It's just pure Python data classes and interfaces. You could take that code out, run it in a CLI, a web framework, or a Discord bot, whatever. The application layer is the second part. This is where the fast API lives. It orchestrates the whole thing. It calls the domain, it talks to the outside world, but it never ever contains the business logic. The last and third one is infrastructure layer. This is where the database connections, RabbitMQ publishers, and Redis lives. Keeping this part isolated from the rest of your code, keep your structure clean. And the best part, folder structure is one-to-one mapping of this architecture layers. Domain, application, infrastructure, it's just right there in the repo. This project uses design patterns. Repository pattern says my business logic doesn't care if you use PostgreSQL or a CSV file. And strategy pattern let you take out the rate limiter with Redis and swap that with an in-memory one. Isn't that beautiful? Alright, I'm gonna walk you through what happens when someone clicks a short link. This is the most important flow in the entire system. The request hits UVCon, that's our server. Then your request goes through middleware layers. First one, CORS layer. Are you allowed to talk to me? Second one, request ID middleware. Each request get a unique UUID slapped on it. Then we hit the rate limiter. Redis checks through a sorted set if this user or IP address has gone over its limit. If yes, then you get a 429 slap. If no, then you are allowed to go. And now the fun part, we check Redis for the shortcode. By shortcode, I mean the shorter URL. If this is in Redis cache, boom, 1 millisecond and you are redirected to your original URL. This is the fast path. But if that cache misses, we fall through the Postgres. That takes 10 to 50 milliseconds. But here's the thing, we write that cache back to the Redis. So the next request for this URL gets a cache hit. Then we check if the link is expired, decide if it's a 301 or 302, and response goes out. The user get redirected. But wait, there's more. After the response is sent, we publish a click event in RabbitMQ. This is fire and forget. User never waits for the analytics to work. They are already on their destination while the analytics are traveling through the queue. That's the key insight. The redirect path is a critical path. Everything else is a background noise. If RabbitMQ is down, users still get redirected to its page. If Redis is down, we get fallback to our database. The redirect must work. Okay. Security in this is like an onion. I have divided that into 7 layers. Let's walk through them one by one. Layer 1, rate limiting. We have talked about this. You stopped some kids from using brute forcing on your endpoints. Layer 2, cores. Your front end is allowed to talk to the back end, no one else is. Layer 3, input validation. Bidentic models stop garbage from reaching your business layer. Layer 4, JWT authentication with HTTP only cookie. You get access token and refresh token. Layer 5, authorization. Admin can moderate the whole thing, but users can manage only their own URLs. Nothing overlaps. Layer 6 is IP hashing. We use SHA-256 to hash your IP addresses to rate limit without storing the IP addresses in plain text. Layer 7 is data retention. We delete click events after 90 days. A salary beat works at 3 AM and deletes all your old data. It's a relief to your database. And here's the thing, if layer 1 fails, layer 2 catches that. Even if layer 4 fails, layer 5 protects the admin points. Layer defenses mean no single point of failure with security. Let's talk about the database. There are 9 tables in this application. See this, the URLs table has total clicks column. This is a denormalized counter for performance. Every time someone gets redirected, we increment this counter. This is fast and a little bit stalled. But clicks hourly is the source of truth. It's an aggregated table. A salary worker runs every hour, collects all the raw click events and places them in beautiful hourly buckets. So if you want to see how many clicks your link got on Tuesday, it's just a select query, not a count on a million rows. And this table right here, idempotency keys. If you send same create URL request with same key, you get the same response. No duplicate links, and this is how usually payment API works, but in this case we are using it for link creation. Okay, so let's talk about the architecture choice. This is a monolith. Here's the honest take. This architecture is over-engineered for this project, but this is perfect for practicing your designing skills. If you are learning something, I would rather study something over-engineered than something that cuts off all the borders. Alright. Let's talk about the background pipelines. Every redirect publishes a click event in RabbitMQ. The redirect handler doesn't wait for the analytics, it just moves on and throws away the event in queue. That event contains shortcode, timestamps, referrer links, and hashed IPs. Salary workers are sitting there listening to this queue. When an event comes in, a worker consumes it and put that into analytics table. If that fails, that event is pushed back to the queue so it can be re-consumed. But if it crashes 3 times, it gets pushed to a dead letter queue, so the admin has to take care of that manually. Salary beat runs 2 tasks. One runs hourly. It reads all the raw events, put them into hourly brackets, and persists them. This is what you see when your API queries your analytics dashboard. And one runs at 3 AM cleaning the data that is older than 90 days. So set it and forget it. Oh, and a fun technical detail. Salary workers are synchronous. They can't use async. So there's a dedicated database connection for this purpose. Workers use synchronous, API uses asynchronous. 2 different drivers, same database, no conflicts. Now the caching strategy. I have used cache aside or lazy loading, and here's how it works. Request comes in for a shortcode. You check in Redis. If it's there, great, return it. If not, query the database, write back into Redis with a 24-hour TTL, and then return it. So the next part gets the cache hit. Cache hit 1 millisecond. Cache miss 10 to 50 milliseconds. Over a million requests, that's a difference in 1 second and a 50 second of work. When a user updates or deletes their link, we invalidate the cache. So a next request get a fresh copy from the database. Stale data stays just for a single request. And because the code uses strategy pattern, the tests for this project just use in-memory. They don't need Redis running at all. So Redis is a force multiplier, but it's not the source of truth. Alright, let's talk about observability. You can't fix what you can't see, right? So we have got all three pillars of observability in this project. And you might ask, is that feasible? And again, this is just for the learning project. We have got structured JSON logs with request ID tying everything together. We have got custom Prometheus metrics like cache hit ratio, queue depth, or database pool utilization. And we have got latency tracking histograms for URL creation and redirect. OpenTelemetry traces every redirect request, so you can exactly see how much time Redis took, how much time Postgres took, and how much time the whole thing took. There's a pre-built dashboard in Grafan which visualizes all this. And the app has health check endpoints. Health says I am alive. Redis says which of the services are available right now. If you are deploying to production and you are not setting up monitoring, that's like driving a car with a blindfold. You don't know that you are about to crash until you crash. Let's talk about the Docker setup. There are 9 services all in Docker Compose YAML file: Postgres, Redis, RabbitMQ, Fast API, Salary Worker, Salary Beat, Prometheus, Grafana, and the frontend. Okay, I know I keep coming back to this, but this is the interesting decision. Why monolith instead of microservices? The reason is this domain is well understood. URL shorteners has been there for a long time. And microservices add some issues like transactional complexities, network latency issues, deployment coordination, and debugging overhead. But because of clean architecture, every component has clear boundaries, but they deploy as a single system. So it's not about debate on microservices versus monolith. It's a what makes sense right now decision. And right now, this is perfect. Storage systems. This one uses 3 storage systems, each for its own purpose because there is no single tool that does all of this. Postgres provides you ACID transactions. You can do data joins, you can do integrity, you can do a fixed schema. This is your source of truth. Redis gives you millisecond reads, automatic key expiries, and atomic operations for rate limiting. This is your speed layer. RabbitMQ gives you async communication and decouples your analytics layer with your redirect layer. When a URL is created, Postgres gets that URL and Redis gets a cached copy. When a click event happens, it goes to RabbitMQ and Salary Worker sends it to Analytics Postgres table. When hourly worker runs, it gets your analytics structured, and at 3 AM your worker deletes old data. So magic is not in any of these systems. It's in how they work together. Each one does what it's best at. So that's pretty much it. A massive code base and a whole lot of architectural decisions that I unpacked for you. Here's what we have covered. Clean architecture, request lifecycle, cache aside, rate limiting, background jobs, security layers, database design, error handling, storage strategy, observability, deployment, and a philosophical debate of monolith versus microservices in this case. If you enjoyed this deep dive, like the video and do let me know in comments what should I do next. I hope you learned something new today. Keep building the cool stuff and I'll see you in the next one.